Okay, today we're going to talk about polar coordinates. Now you're used to rectangular coordinates, which are, 3, 4. We measure a horizontal distance and a vertical distance. With polar coordinates, let's do a different. We're going to do a different one that's a little easier. Sometimes we'll measure and a radius. So a radius and an angle. So instead of horizontal, vertical, we measure radius, angle. To convert, I just draw in the right triangle. This is a 30, 60, 90. So I happen to know what this one is without having to use sine or cosine. Okay. Oftentimes polar coordinates are given in. So here we'll go 7, 5 pi over 6. So now I'm in radians. Now this is kind of great, because all I have to do is put in my trig ratios. And I can do this. This one happens to be on the unit circle, but I could do this with a calculator if it's not. So to convert, my x-coordinate is 7 times the cosine of 5 pi over 6. Now the cosine of 5 pi over 6, that's my x-coordinate. My y is 7 times the sine of 5 pi over 6. The cosine of 5 pi over 6, my unit circle tells me is negative square root of 3 over 2. The sine is 1/2. So my rectangular coordinates are negative 7 square root of 3 over 2 and 7 over 2. Okay, so to convert, cosine is going to give me my angle. Again, here's my triangle here. My little reference angle alpha, adjacent x over hypotenuse 7. I know cosine of alpha equals x over 7. But if I want, and because the cosine, it's got to be a negative. If I want the cosine of theta, it's just positive x over 7. And 7 cosine theta is always going to give me my x-coordinate when the radius is 7. So converting from polar coordinates to rectangular coordinates is pretty nice. Graphing polar coordinates, again, I just found my angle 5 pi over 6 here. It's 150 degrees from the positive x-axis. And then I put a radius of 7. Go out to something that's got a radius 7. Okay. If I say, let's do a different color. If I say here negative 7, 150, I go to my 5 pi over 6 and I just go the opposite way, 7. I guess this isn't a vector. This isn't a vector. It's no arrow on the end. It's a point. Okay. Converting from polar coordinates to rectangular coordinates, really nice and straightforward. You just have to use trigonometry, and you've got to draw pictures. Okay. You can also go rectangular to polar, which let's do one that's pretty straightforward. We'll go back to we're going to do 3, negative 4. So that's here. Three, negative 4, 3, 4, 5, right triangle. To get my angle in here, I'll do an inverse tangent. of opposite -4/3. We'll grab a calculator on. And I get -53.1. So I can call it this. I'm doing degrees. You could also do radians. Or I can add 360 to that and have the positive angle. Okay. Not sure why I kept an extra decimal there. Distance in the polar coordinate system. I'm going to find the distance between these 2 points. There's a couple of different ways I can do this. I can convert each point to rectangular coordinates and use the regular old distance formula. 2 and pi is right here. It's -2, 0. 3 and -3 pi over 4 is going to be right about here with this at 3. Okay. Not sure exactly what angle that is. Or you can use essentially the law of cosines, law of cosines. Because I have a triangle here, and this angle is beautifully θ1 minus θ2. So applying that here, I get the square root of 2 squared plus 3 squared minus 2 times 3. I guess I'm swapping those. It doesn't really matter. They're multiplied. Cosine of pi minus -3 pi over 4. And when I do that, important that I switch to radian up here. I get a distance, which actually looks about right, of 2.12. Okay, so finding distance at polar coordinates is really just using the law of cosines to figure this out. That is polar coordinates.